Okay, so today we are going to see how to detect a custom object using the ImageAI library and using the transfer learning technology in artificial neural networks. So the objective of today is to build a model to detect tuk-tuks. So let's see how we can do this thing. So if you have watched our previous video, we have used the ResNet 50 Cocoa based pre-trained model to detect few objects. So as you can see in this image, we have been able to detect most of the objects in this street view, but you can see that we couldn't detect, the system did not detect this tuk-tuk. The reason is the ResNet Cocoa based model is not trained with tuk-tuk, so it doesn't recognize this thing. And even you can see that it even detect the person inside of this tuk-tuk but not the vehicle itself. So let's see how we can do this. So to do this, we can use the technique called transfer learning. In here what we can do is we can use the same pre-trained model with no tuk-tuk data, and we can have our label data set with many tuk-tuks, images of many tuk-tuks, and we can have our labels with this tuk-tuk, and we can feed these labels into the neural network and train the model and output the train model H55. So this is the objective. So after we get the train model, we can feed in this image, and the system should be able to identify this tuk-tuk. Okay, so the first problem that we are facing is where to find these labeled data images or this labeled data set for tuk-tuks. So these are the normal places or the standard places that where you can find these labeled images. So let's go into this Google image set and try to identify these images. So you can see, so this is the URL. You can go to this URL by yourself and try to identify these images. So these in here you can search for your whatever the image type that you want. You can see for cars, aircraft, and all these things are there. But if you're trying to search tuk-tuk, it's not there. And we can try other things such as three-wheel. It's not there. Trishow is another name for tuk-tuk. It's not there. So technically, uh, actually, I haven't been able to find any tuk-tuk image in any of the internet data sources or these data models. So now we have a problem. So how we can uh, overcome this? So in order to do this thing, we can use an annotation tool called label image. So label image is the tool that we are using to create annotations. So I'm using my Windows system to create these annotations. So let's open up the label image. So this is the basic user interface that you are having. So first of all, we'll open up our data directory. So in my case, it is in this particular folder. So I'm opening up the folder. So you will be able to see that all the images are added to the tool. So in here, we have to select the format that we are going to create our annotations. So this label image tool supports two annotation types, YOLO and Pascal VOC. So we are going to use the Pascal VOC. So then we are going to use the create rect toolbox and draw toolbox in this way. And then we have to give the label for this bounding box. Here there are two tuk-tuks. Label. Then we can save the image like this, and then move into the next image. So I'm going to create the bounding box into this image as well. And the label. and save this image. So let's go into this particular folder and see how the annotations been done. So let's open up the first image. You can see that it's took the name of my JPEG file and the path, and we had two tuk-tuks in that particular image. So you can see that it's gave the particular references for the x and y location of the starting point, and the boxes height and width properties. There are two labels in it. After doing the annotation, so you need to organize your folder in this format. So this is the root folder, and you have to have two folders inside that. For the one thing is for the neural network training set, another one is for the validation set. So let's go inside to the training set. You have to have two folders again inside this folder. One is for the images. So these are the tuk-tuk images that we are going to use for our training purposes, and the respective annotations of each of these images. And we have to make sure that the image name and the annotation names are same. So let's open up one annotation and see. You can see as you have seen earlier that it has one tuk-tuk image and with the respecting bounding boxes. So after do that, we have to have the same set of format in the validation set as well, set of images for uh, validation and respective annotations. So let's go to the code. So this is the code that we are going to use for the training purpose with transfer learning. So first of all, we need to import the detection model trainer from ImageAI, and then we have to create the object from the detection model trainer as trainer in this example, and then we have to set the training type as YOLO v3, and then we have to set the data directory. So this data directory that I have explained to you, it has two folders inside the train and validation, and we have to set the train configurations. So the most important thing is the labels that we are going to use. So if you remember that we have labeled our annotations using tuk-tuk. So if you have more labels, then you can have comma separated values in here, and we are using the pre-trained YOLO 3 H5 file as well as our pre-trained model. So in here we can use the trainer.train model method to train the our tuk-tuk detection model. So if you are trying to train this thing using your local system, so this is what would happen. So this is after like few seconds of training in my laptop. You can see there's a high number of CPU usage and memory usage as well, because this training is a very incentive process to a normal laptop or a computer. So how you can overcome this problem? Now to overcome this problem, Google is giving us some free tool called Google Colab or Collaboration Laboratory. So in here you can use, if you go to runtime, you can use the Google GPUs. You know that whenever that we are using GPUs, we can get some good output from high processor incentive processors such as this training. So what we have to do is we have to upload your respective files. So I have uploaded my pre-trained YOLO v3 h5 file, and you have to zip your tuk-tuk root folder and upload it into here. So as the first step, you have to install the TensorFlow GPU. So I'm using version 1.13. So this is the most latest version as of this recording. You have to wait a little bit until it's downloads. And after that you have to install the ImageAI using the pip tool, and you have to unzip the tuk to zip file as well. So until this one is getting done, I am trying to unzip this. You see that is finally successfully installed. Part, and the unzip is also done, and I'm installing the ImageAI library as well. This, so that is also done. So I'm going to refresh this folder. You can see that the file is updated properly, and finally we have to train the model. So this is the same code that I have shown you earlier. So I have pointed my data directory into tuk2, which is this directory, and I'm using the label and the pre-trained model. So let's start train this. So even with this thing is taking a little bit of time, you can see that it's throwing up few errors and all. So unless if it is a showstopper, you can continue. It's trying to start the training using the transfer learning method. So this one also would take a bit of time, so I will pause the video until the training is completed. Okay, so after the training being done in Google Colab environment, so we have to download this mainly the trained H5 file and the respective detection config JSON file from the Google Colab environment, and you can set it up in your local environment. So this is the code to the detection. So in this phase we are going to do the tuk detection. So let's go through the code. So in here I'm downloading or importing the custom object detection model from ImageAI, and after that I'm invoking the detector object using the custom object detection class, and then I'm setting the type as YOLO v3, and for the model path I'm selecting the downloaded H5 or the trained H5 files model path and the JSON path as well for the detection config JSON, and then I'm loading the model. And in this phase I'm going to do the detection using this command or this particular line of code called detect objects from image. So let's run this code. So running it one by one, then I'm trying to detect the image. You can see now in this file we have been uh, successfully able to detect this particular tuk with the 72.7 of confidence. So you can see that this is the bounding box that is being created in this particular image. So likewise we can use this transfer learning method to train any custom object and create a bounding box by bounding box on top of this custom object.